Okay, this is just a quick look at a little simulator for logic gates. So this is a way of playing around with digital circuits. You can actually build digital circuits on here and test them. But it's also going to show you how to visualize a NAND gate, N-A-N-D, and a NOR gate, N-O-R. And like I said, your NOR gate and your NAND gate are just your AND and OR gates with a NOT gate attached to the output. So I'll show you that now. What you can do is if you want to grab a NAND gate, you can grab it from down the bottom here. You just click once on it, and then you go up onto your circuit board, and you click again, and there's your NAND gate. And it looks just like our AND gate, but it's got a little circle at the top of it, which tells you that the output is inverted. And another way I could create that same gate is I could just grab my standard AND gate, and I'll put that to the right. And as you can see, the output doesn't have a circle on the top. Just ignore those other little circles because they are where the actual the wires get attached. I'm talking about the actual top of the arc there. You can see a little circle. So that you can see these two different symbols are different. The one on the left is your NAND gate. The one on your right is your AND gate. The one on the left, the output is inverted. So if I wanted to turn this AND gate that is on the right into a NAND gate, all I need to do is I grab my NOT gate or my inverter gate, and I would need to just move it so that it's attached to the output. And when you want to attach outputs together, you just make sure the little circles are overlapping. And there you go. So the circuit on the right now is exactly the same as the circuit on the left. On the right now we have an AND gate with the NOT gate on the output. So that's an AND gate. So if you're trying to remember how your NAND gate would actually operate, what you might want to do is say to yourself, it's an AND gate up to the input of that NOT gate on the output, and then you just change states. So if there was a 1 at the output of the AND gate, it will be turning to a 0. If there's a 0, it will turn to a 1. So probably the easiest way to do this is actually make the circuit happen. So we can grab a 1 here, and we can place it on the output. Oh, sorry, on the input. And we'll grab another 1 as a positive input, and we will drag it up to here. So we know that if there was a 1 and a 1, the output from that AND gate will be a 1, but it's being fed into that NOT gate. So what do you think is going to happen? Well, it's pretty obvious that your 1 state will be flipped to a 0, because that's what a NOT gate does. So we were to grab an LED here, we know that our LED will be switched off. And we can actually test this circuit if we want to try it. We go up here and we just hit play. Now the light shouldn't come on, and it hasn't come on. Now if I was to change one of these input states to a 0, we'll just hit stop here. You know that for an AND gate to be on, you need a 1 and a 1. So once you've got a 0 happening in the input, this output will go to 0. So when that goes to 0, it will change the 0 to a 1 and the light will come on. So I'm just going to grab a 0 input. I'm going to grab one of my 1 states here, and I'm going to feed that in there. If I was to hit play now, it comes on. And we know that we've actually created the same gate as the NAND gate on the left, because if I grab a 1 and a 0 and use my NAND gate on the left, a bit of finger trouble here, and then I grab my LED, on the output, it should, in theory, come on, and it has. So you can see here that you can recreate a NAND gate by just getting an AND gate and putting an inverter on the output. I would encourage you now to grab an OR gate and attach a NOT gate to the output, and just verify for yourself that this circuit here behaves just the same as an OR gate. And like I said, just concentrate on thinking about it, the output for given inputs as an OR gate, and then just flip it once it goes into that gate there. And that might be a way of remembering how a NAND gate and a NOR gate works, just by remembering how your OR and AND gates work. It's a way of building on knowledge you already have without having to remember all these different truth tables. It's called logic circuits for a reason. There is a certain amount of logic to the whole process. I'm hoping this has been helpful, and it'll help you remember how to do those harder questions that we have to do in the paper. I will be doing an example towards the end of this page.